Olá, pessoal. Meu nome é Luiz Maia. Eu estou aqui para mais uma sessão gravada da disciplina Economia Comportamental de Questões Globais. Hi, everybody. We are speaking in English in this class, or at least in poor English. All right. So very good to have you all here. We are recording this session just to introduce some of the topics that we will discuss in our next meeting. Okay. So I want to talk a little bit today about the prospect theory. This is a very important part of behavioral economics in general, and we're going to try to see how these advances in economic theory bring us new perspectives to understand and to deal with global issues. All right? So let's start with the beginning. Whenever we talk about prospect theory, we have to remember this paper, esse artigo que foi publicado em 1979. This paper published in 1979, Prospect Theory and Analysis of Decision Under Risk. Now, please notice that this paper was published by two psychologists, Daniel Kahneman and Amos Tversky. These guys are not economists, but they published in one of the most important journals of economics, Econometrica. So this is kind of surprising thing. It turns out that this is not only surprising because it was published by two psychologists, but also because this one ended up being the most cited paper in the history of economics. Oh, not only in the history of economics, of any papers published in economics and business administration, business magazines, economics journals. This one was the most cited paper ever. Well, think about it. If you are not taking this class, you would soon become an economist and never have read such an important piece of contribution to economics. So I think this is a big deal, and we should all have a look at this paper. So what it does, it actually presents a critique of expected utility theory. We're going to go back to expected utility theory in just a bit, all right? But then these guys are criticizing expected utility theory, and not only that, but they are proposing an alternative model, which is called prospect theory. The context of all this is decision-making under risks. When you have to make a choice, but you are not pretty sure which are the probabilities, or, well, you actually know the probabilities, but you don't know what's going to be the outcome of your choice. It's like a bet. When you have to make a bet and you don't know what's going to end up having, right? What you're going to end up having. So suppose that you make an investment and you choose some sort of financial deal and you expect some results, but sometimes bad things happen in the meantime and you don't know exactly what your return will be, okay? So decisions under risks, well, they are a big deal not only in financial deals, but also in our everyday life too. We're going to try to see that, okay? All right, so these two guys, I believe you know, they received the Nobel Prize in 2002 for this and some other contributions that they made for the economic theory. All right, some points that we want to highlight from the beginning. First is what they called certainty effect. What is that? Well, it is the tendency of people underweighting outcomes that are merely probable in comparison with outcomes that are obtained with certainty. So when there is probabilities and certainty, you have option to have a certain outcome with certainty and there is some risk involved. You could get another deal, but then you're going to have some probability of losing money or not getting any money. Turns out that we make strange decisions in such a context. This observation and this certainty effect, it contributes to risk aversion in choices involving sure gain and risk seeking in choices involving sure loss. So basically, it turns out that if we have a deal that is certain, you can gain some money, you can receive some benefit with certainty, and you could have some other outcomes with different probabilities. We tend to play safe and to go for certainty when gains are involved. On the other hand, when losses are involved, we tend to be risk takers. We would appreciate, we understand that we have to run some risks, and then we tend to take more risks when we are trying to escape from losses. All right? The second point we want to highlight is isolation effect. People generally discard components that are shared by all options under consideration. So you have like to make a choice and you have 6 different options. When it turns out that when some aspect of those options are shared by all of them, then we tend to ignore those and we will only make choices based on what is different. It seems reasonable, right? It seems rational to do so, but it turns out these guys have shown that such a feature in human reasoning, it leads to inconsistent preferences, which means we make choices and sometimes we seem to have changed our behavior, our preferences, and we make choices that do not look like us. All right. Finally, we want to highlight the overweighting of low probabilities. So it turns out that when there is a small probability of something happening, but there is some probability of something happening, even though the probability may be small, we get scared and we overweight events that are very unlikely. And we do the opposite with events that are more likely. When events are very likely, we tend to underestimate whenever there is some chance that things will not go the way we expect. But then there is this kind of calibration or subjective probability, and we're going to talk about that in a few minutes, okay? Or maybe in our meeting, in our next meeting, all right? Okay, so let's get a quick reminder about expected utility. So here we are talking about the satisfaction that one may get with a deal, and some outcomes are more likely than others. And we say, what is my satisfaction? What is my expected utility of having a bet in which 60% chance I'm going to win 100 reais and 40% chance I'm going to lose 20 reais or something like that. So we're going to say that this sort of bet, it brings us some form of satisfaction. And different bets may end up having for us different levels of satisfaction. But the way we calculate that, according to expected utility theory, is that agents risks decision. Well, the satisfaction that we derive from these risky decisions is a mathematical expression, a mathematical expectation of this utility from different outcomes given their probability. It's kind of confusing. Well, it turns out that it is the weighted average of satisfaction from different possible outcomes. So if there's like 20% chance I'm going to win 100, I'm going to multiply 20%, 0.20, by 100. And there is 80% chance I'm going to win 700. I'm going to add up 0.8 times 700, right? So we make this weighted average of outcomes, and the weights are basically the probability. All right. So that's how economists have for a long time proposed to evaluate the satisfaction, the level of satisfaction that we can get from risky decisions, all right? And then here comes these guys and propose those experiments. So let's go back to our experiments, all right? First problem. Here's the deal. You can receive 2,500 reais with probability of 1/3, 0.33%, all right? Then you can have 2,400 reais, a little bit less, with probability of 66%, almost 2/3, right? And you still can get 0 with probability of 1%. So it seems like it's very unlikely you're going to get 0, but there is a chance that you can get 0. So this is option A. Let's compare that with option B. You get 2,400 with certainty right now. If you present people these choices, what you observe is that 82% of the people will pick option B. They say, yeah, it is certainty, 2,400 reais right now. Yeah, it's great. I'm not going to buy any lottery ticket, whatever it is you're offering. I want certainty. But we can calculate what this means, right? So you have the utility of getting 2,400 right now. It's considered greater than the utility we may have from 0.33% or 33% chance of getting 2,500 plus 0.66 times the utility of getting 2,400. You could also have here the 0.01 probability multiplied by 0, but then that's also 0. So what we are saying here is that this deal, the utility derived from getting 2,400 for certain, is larger than this deal, these two options that we have here. We can rearrange those terms. We can move this guy over here, and then we subtract minus 0.66 out of 1, and we're going to get 0.34 times the utility of 2,400 is greater than 0.33 times the utility of 2,500. All right, so this is what we just learned from people's choices, right? Okay, pay attention to this thing here. I'm going to show you quite the opposite right now. Okay, so here comes problem 2. What do you prefer? I can give you 0.33, 2,500 reais with probability of 1/3, or I can give you 2,400 reais with probability of 0.34. What would you like? Slightly less likely chance, slightly smaller chance of getting 2,500, or a little bit more likely option to get 2,400. It turns out that when people are presented these two options, what they do, they pick the other one. They say, you know what? I prefer taking this option C. Afterwards, after all, it's just like a little bit more money, 100 reais higher amount, and the probability is practically the same. So that's how people choose in this case. But if you put that in a mathematical expression, you're just denying what we have just shown above. Check out this expression here. 0.35, 0.24 times the utility of 2,400. It is smaller than 0.33 times utility of 2,500. If you go back to the previous slide, check what you got there. It's just the opposite. 0.34 multiplied by a utility of 2400 is greater than 0.33 times the utility of 2500. So your choices have been shown to be inconsistent. All right. So what these two guys do is to propose lots and lots of examples like this, and they started to realize that there were some problems with expected utility theory. Okay, no big deal there. Many people can find problems in theories, and they basically say that those are exceptions. But if you show that a certain theory, it has lots and lots and lots of exceptions, and important ones, then at some point you're going to say, well, we need some other theory. We need a better theory. And that's basically what happened, right? But I want to create this kind of tension now, and I want to tease you a little bit. Pay attention to this question, please. What would your response be if, for example, one day you were teaching economics and some smart student presented this example that we have just seen to criticize your theory? So let's suppose you are a professor, and then here comes the student, and he shows up this experiment, and he say, look, your theory has a problem. What would you answer? Would you actually think that I have to change my theory? Would you agree that the theory has some important flaws, and then I would have to search for some alternative? How compelling do you think that Tversky and Kahneman had to be to get this paper published in Econometrica, one of the most prestigious journals in the world? Well, they had to make a good case, right? The paper should be something very amazing, spectacular, and it actually was. It was very creative, and it was very thoughtfully presented, right? But think about it for a moment. Who are the real adversaries of innovation? Who is against innovation? What these guys are showing up and saying is like, here, I have an innovation. I have a new theory. It's absolutely groundbreaking. It does much better than your standard theory. What plays against those proposals? What it is against? What are the enemies of this sort of innovation? Well, I'll tell you what, human brain. We talked a little bit earlier about cognitive biases, and I remember mentioning to you guys that even though we are aware we are susceptible to these cognitive biases, we don't get cured of them just because we know of their existence. Saber-se míope não cura a miopia. A pessoa tem que usar óculos. Mesmo que ela saiba que a sua visão distorce os objetos a uma maior distância, a sabedoria, o conhecimento desse fato não melhora a minha miopia. Same thing with cognitive biases. We know that they are there, but knowing them doesn't make us less susceptible to them. So you have to understand that when the revisers, the guys who actually analyze the paper before accepting it for publication, these guys face this enemies. First, conservatism, the tendency to revise one's beliefs insufficiently even when presented with new evidence. And here comes Tversky and Kahneman say, I have new evidence. I can show you, I can prove to you that this theory does better than the standard one. Will you revise your opinion? The second one, hindsight bias, sometimes called the Oh, I knew it all along. So people look at this and say, yeah, we know that. We are aware of those problems. Those are not important. Those are just some anomalies. Yeah, it happens in every theory, in every science. Uh, Maybe they are not that important as you think they are. We knew about them. You see, these guys, after someone shows you something that is uh, absolutely groundbreaking, and you try to put it down a little bit and say, yeah, we knew it. Yeah, it's not a big deal. This is not about cultural features of any nationality. We are not talking about German people, American people, or Brazilian people. We are talking about the human brain. The human brain works like this. We are all susceptible to these kinds of cognitive biases. The third one, status quo bias, the tendency to like things to stay relatively the same. Think about this. You are like one of two or three reviewers for this magazine, and here comes someone and saying, you're gonna have to rethink, start over in things that you have done for a long time. That's kind of not comfortable at all, you know? It provokes you. It sometimes may be like an aggression. You may feel like, you know what? I don't like this. I like to things to stay the way they are. And we keep going. Ambiguity effect, we say, yeah, it sounds interesting, but maybe this is not yet a new theory. Go back and publish some more. Sometimes later you can try econometric again. They could have done that. The framing effect. Is this an anomaly or is this a huge problem in the conventional theory? The way you frame it, it may give more importance to it or less importance to it. The bandwagon effect. No one has published papers like this. Why would I? No one has published papers from psychologists in an economics journal. Why should us? So if no one is doing something, maybe we should not do that too. Group thinking, herd behavior, feito manada, remember? Bias blind spot. Other people are biased. We are not. So they come and say, oh, come on, these guys are trying to say that they are going to invent the world all of a sudden. We know better. We can check. We can see very clearly what is the actual importance of this contribution, and maybe it's not econometric stuff. Endowment effect. Some of these reviewers, they have published papers using expected utility theory. So all of a sudden, they may be kind of outdated, obsolete. How can you say yes to a theory or to a paper which will ultimately render your work obsolete? That doesn't sound very good, right? We also have the confirmation bias, something that I have stressed out a lot, highlighted. Confirmation bias is a big deal. We have science, basically, because we need to protect ourselves and our civilization from confirmation bias. Our tendency to search for and focus on information that confirms our perception. We don't want to change that perception. Whatever is against what we believe, it's not comfortable for us. It's not um, pleasant for us to deal with, right? So when Econometrica went ahead and accepted this paper for publication, these guys had actually fought against all of these tendencies. So it was a huge accomplishment, not only for Tversky and Kahneman, but for these guys. They actually said, you know what? This is very important stuff. It doesn't matter how much that may be uh, unpleasant for some of our most important distinguished professors. They are going to have to deal with it. So this is the kind of stuff that in many countries, innovation is actually um, much harder because of that. People don't accept new ways to look, don't accept new proposals, but fortunately, that was not the case in the US. All right, so let's try and finish this recorded session, short one, just talking about these two curves, which in some ways they summarize the most important ideas about prospect theory. I'm going to start with the diagram on your left. You can see here what you see in this first area of the diagram, the right hand upward side, where it's written concavity. Well, notice what we have here. We have an utility function. As you have more money or more goods or something that brings you pleasure, satisfaction, you get more utility, but there's some sort of satisfaction or satiation, and then at some point you still get more utility, but you're growing your level of satisfaction in a smaller rate, right? We call this concavity, and when we are dealing with risky choices, concavity basically means risk aversion. What is risk aversion again? Well, the tendency that we all have to avoid risks. If you can get a certain deal and you could get a deal involving risks, you're going to tend, generally speaking, you're going to tend to move towards certainty, right? Nobody chooses to take risks just for that, just for risks, right? Or at least not many people do. So here's what we have. This is conventional utility theory. But then, when you're talking not about gaining, receiving money, but losing money, notice what we see here. Instead of going the same way, if this curve was supposed to go the same way it was before the reference point here, we would see it falling faster and faster, right? But that's not what we observe in people's behavior. You see convexity, which is the opposite of concavity. You see convexity, and you see the slopes of this curve and that curve. The slopes are completely different. So let's try and understand this. Convexity means that you don't want to lose money, and the more you lose, the more you try to avoid losing it, right? But if you are already losing a lot of money, well, you're going to try any risky choices you may have. So you become a risky lover, a risk lover if you are talking about losses. And if you're talking about gains, people rationally, most of the people will behave as risk averse agents, okay? So this is the first thing. The second thing is about the slopes. The slopes here are, the curve is flatter, it's closer to a straight line, horizontal line. This one here is steeper. It falls down really fast. What does that mean? Well, it means that we hate losses. We like gains. Everybody likes to have benefits, right? Obviously. But we hate losses. So here comes again the idea of loss aversion. We losing 100 reais or losing a 100 reais bill, it costs us, it damages our level of satisfaction much, much more than receiving 100 reais, right? The loss is felt more intensively than the gain is. All right, so this is the general idea about loss aversion, and also about risk aversion when we are talking about gains, and risk loving or risk taking when we are talking about losses, all right? That explains a lot of those problems that we saw Kahneman and Tversky proposing. The second point is how we deal with probability. Now, this is a simple diagram. It doesn't look like a simple one, but it is. Here, what you have is the actual probability. And here is what you have is what is the felt probability. So if the probability of some event or outcome is 10%, we tend to think that it is as big as 20%. So it's like, when I offer you a deal in which you're going to make some money with 10% chance, if the probability it is small, as we make decisions, we tend to express those choices or make those choices as if the probability was larger. We overestimate the importance of small probabilities. And the opposite happens when you're talking about large probabilities. When you're talking about 90% probability of something happening, the actual choices of people show that they are they are making choices as if the probability was actually 70%. You know, if I tell you that something will happen with 90%, your actual choices will be as if you were actually associating a 70% probability of that thing happening. And you can only see that from the actual choices, right? You can see people's actual choices and compare with what the conventional theory would expect. The conventional rationality, risk aversion theory, the conventional expected utility theory. So what we see here is that these guys are dealing with different concepts compared to expected utility theory. Here we are talking about loss aversion, we are talking about value function, we are talking about subjective probability. So these guys introduced human reasoning in decision-making analysis. Can you guys see that? Well, we're going to make sure that you all understand those ideas. I'm going to stop here. This was actually supposed to be a short session, and I hope I have teased you, provoked you enough that you will all show up on Friday, and we are going to have good discussions about this. But please remember, we're going to bring those ideas to real life, to real global problems, okay? Things that are important all over the world. Okay, guys, thank you. Keep watching and keep talking to us. We're going to have very good discussions over WhatsApp groups or in our meetings. Take care. Bye-bye.